Good, cool. How's everyone doing? We're really excited to be here for the second year in a row, but this time on the stage. It's going to be. We are aware that the only thing standing between you and your lunch is this presentation, so we're going to try to be as quick as possible. I'm Adela, this is James, and today we're going to talk about how we got from having slow, flaky, and legacy tests to where we are today with a new testing strategy, new ways of working, and our new test runner. And just in case you were wondering what FTFY means, fix that for you, and you'll know why by the end of this presentation. Just bear with me. Cool. But before we get to the agenda for today, I just wanted to say a few words about who we are. Net-a-Porter is an online luxury retailer with websites such as Net-a-Porter, Mr. Porter, and The Outlet. Now be honest, how many of you shop on these websites? Can I get a show of hands? Yeah, cool. The reason why I was asking is because we've got customers from all over the world, but almost 40% are from the US. Also, we have more than 3 million page views during a sale day. So we're like Amazon, but smaller. Yeah. Cool. So this is the agenda for today. We're going to talk a little bit about our browser matrix, technologies that we currently use, which ties in nicely with our old and current architecture, our testing culture, CI pipeline, new tooling, and our famous test runner. Yeah, cool. Let's start with our browser matrix. I think we are lucky in the sense that our customers are early adopters, which means we have the luxury to run our tests on the latest version of Chrome, latest version of every browser that we've added as part of our matrix. And also, we're not bound to support all the older versions, which is quite cool. This is just a slice of our browser matrix. And just in case you notice, the numbers don't add up, so it's just a slice. Yeah, our customers prefer to use Safari on a Mac or on iMac, so the latest version of Safari. And the same applies for mobile devices, and that's latest iPhone and latest Android. Later on in the presentation, we're going to talk about how we run all our tests in Source Labs using this browser matrix, and how we run them in parallel. But before I talk about the technologies that we use, I just wanted to give you an example of two of our microservices, which is, the first one is the listing app on the Mac and iPhone. That's actually a listing page with all the items that we've got on the website, where you can paginate, you can sort, you can filter by a designer. On the iPad, you've got the product tab, which is actually the product details page, where you've got the images, you can add to your shopping bag, and you can check other functionality like size and fit. Cool. I think we've got to the point where I can start my story, or where our journey begins. And this was roughly 2.5 or maybe 3 years ago. We used to have a monolithic web app written in Java, and in a completely separate way, we had our testing framework. To write our tests, we were using Selenium WebDriver, Java, Cucumber, and to run our tests on different browsers, Chrome, Safari, IE, we were using Selenium Grid. You can also see at the bottom our testing utils library, where we were actually defining our desired capabilities, where we were defining, in case we wanted to run our test in Selenium Grid, we were basically defining a new remote WebDriver. Also, waiting methods in case you wanted an implicit wait or an explicit wait. It's worth mentioning that we kept on adding tests to that testing framework, and at some point I think we ended up with more than 800 tests running overnight. our web app was channelized, which meant we had 3 completely separate test jobs. And if you wanted a full regression suite, that would have taken, I think, 6 hours. So again, we were running them overnight. Of course, when you're running that amount of tests, you are bound to have a few failures. So every single morning, more often than not, we had red builds. So one of us, the lucky one, just went in and had to go through every single failure and check whether that was indeed a failure, an issue actually, or just an environmental issue at that point. Imagine another interesting thing to mention is the fact that we just decided to run all these tests, so 6 hours, just in Chrome. We were only using Selenium Grid to run the tests in Safari or IE in case we needed to do a proper cross-browser testing. Maintaining Selenium Grid, painful, to say the least. So when the business decided to undergo a replatforming, that was really exciting for us. So this is where the next chapter begins. The first thing we did, because replatforming, that means you're looking at your architecture, you're looking at what sort of changes or improvements you can do in terms of, how can you improve testing in our case. So the first thing we did was to start breaking down the web app into smaller microservices. Those 4 dots that you've got on the right side means we've got other microservices, but for the sake of this presentation, I just picked 2. If you remember the listing app and the product app from the previous slide. So we started rewriting these applications using Node.js and also started hosting them in AWS. And I'm pretty sure everyone here knows the advantages of using AWS. And for us, one of the most important ones was the fact that we were releasing as many times as needed and within a day. I forgot to mention that we were releasing the web app every 2 to 3 weeks at that point, so it was fine if we wanted to run the regression suite for a full day and just look at those failures. But when you have microservices and you want to have an early feedback, that's when you start rethinking your testing strategy. So what we decided was, let's just add some functional tests within every single application. So we have the listing app, just write a few functional tests to check the main functionality. So let's say when you want to make a change within a listing app, you don't require to run the whole testing framework. You basically run those functional tests within the app, and then you can just release it. Right at the bottom, you've got the integration testing block, and that's actually the testing framework, which we basically started thinning out. Just because adding functional tests within every single app means you build confidence. You don't require that amount of tests in the regression suite. You're basically checking the integration between every single application. So I think we ended up from having 800 tests to keeping 10 or 15%, not just 10 tests, but 10%. Another thing worth mentioning, and you can see it there, we started using Sauce Labs, which made our lives easier. We were running all these tests using the browser matrix that I just showed you earlier, and just one click away, we started running all our tests in Sauce Labs. Every single application, as you can see there, one has JavaScript, functional tests written in JavaScript and using WebDriver IO. The other one has, the product app has functional tests written in Java. So it was just a mix of technologies, and the reason behind that is that the new approach was not fully aligned. So you had dev tests writing functional tests in Java, you had developers writing JavaScript tests. So it was just a mix. Things have improved. Of course, there's a chapter 3, and that's where we made other changes, and we got to this point where our CI pipeline looks like this. This is for all our applications which are now in production. And this is actually the flow. Once you commit to master, this applies for both listing app and product app. So it's one CI pipeline for every single microservice that we've got. So once you commit to master, I hope you can see. Once you commit to master, you've got the first block, which is the build. And as part of our build, we've got several build steps. The first one is the standard unit test, where you run your unit test, and then the second one is our in-app functional test and other types of tests that we do. When and if the build is green, we promote automatically to a dev environment, and that's when we run our thinned out integration tests. Also, we run some contract tests as well, and just in case we need some UAT as well. Promoting to live, we still have a manual button, or we still have to push a button, just because we haven't. We want to be we want to have that option. But once the change is in live, we just run another suite of tests, which is basically checking the main functionality. If the website is still, you can still shop, and yeah, you can complete the user journey. So a live sanity for desktop, for mobile, and also our visual tests, which are basically checking if the layout is still correct. Cool. And this brings me to our testing culture. I'm pretty sure you've noticed the fact that I said we. Every single time I mentioned the fact that we had a look at what sort of changes we can make when to improve our testing. We had a look at our architecture and how we want to rewrite things. So every single time there was a we, and that meant the entire team was involved. Because we used to work like this. We had a complete separation between developers and developers in test, or test analysts. And so the first part was when the new feature got implemented, the code was written, configuration design, and then only after the change was in a development environment, that's when the developer in test started writing the functional tests. But with the new approach in mind, and with everyone being on the same page, we ended up working like this, or we currently work like this. And that's, we have a pair, or a pair is assigned on every single story. A pair can be either a developer working with another developer, or a developer with a developer in test. And they go from writing unit tests, then implementing the new functionality, writing functional tests, and all the way to having the new change released in live. And that's why I was saying earlier, we could not have been in this situation without everyone being involved and everyone being on the same page. New tooling. I think I'm going to leave James to talk a little bit about how we run our tests in Source Labs, how we've got to the point where we've parallelized all our tests, how we've, what else? I think I'm going to leave James to walk you through the bit.
Cool. Thanks, Adela. Yeah, so you can see we had pretty good processes existing. How can we really improve on it, and why would we want to? I guess with any software development, you always want things to be better, and there's always an opportunity to do that. So we want our tests that we run to be faster, more reliable, consistent, and easier to run. As you could see before, we had tests in Java and the application in JavaScript. If we're all working together, you don't want to be context switching as much. When they're all aligned, it's a lot easier to do this. So we're still running all our tests in CI. All that hasn't changed at all. Just the actual implementation has changed. The main reasons for this are there's sort of two key tech changes that have happened in the last couple of years. You're probably very familiar with well, definitely with one of them. That's Docker. Containerizing everything just gives us a lot more freedom to do everything we want. And we're quite lucky that our CI/CD team has given us Docker and CI, and we basically have a sandbox to build our own pipelines, which is great. Also, there's JavaScript moves very quickly, as I'm sure you're all aware, having to deal with front-end single-page apps most of the day. But yeah, so we can, by leveraging these two improvements, we can try and align all our testing further, simplify it a bit, and containerize everything. So this isn't JavaScript talk, so I might skim over this a bit quicker because other people use different test frameworks, but we use the WebDriver IO framework because it's pretty great. It's probably the gold standard for JavaScript testing. But we've made sure that we align our new test strategy with async await JS. If you aren't familiar with it, it's a neater way of writing asynchronous code rather than promises, which is how you previously had to do things in JavaScript. If you're trying to do lots of complex assertions and finding elements, having lots of things in .thens gets very painful. I've got a demo of, this is an admittedly very simple test, but this is the old way of doing it, whereas if you do async await, it looks more like this. So it reads how, if you're a tester, you're more familiar with sort of the Cucumber style sort of synchronous tests, and it's the real JavaScript way of writing asynchronous code. I've noticed the WebDriver IO test runner actually provides a parameter where you can write your tests without the awaits, but it runs synchronously, even though the actions are asynchronous. So yeah, this is the big one. We added a lot more flexibility with using Docker in our CI pipeline, and also because everything's contained in that, the environment's all completely consistent, we can easily replicate this locally. So if you want to run your functional test in your app with all the services you need, you can replicate it exactly on your machine, and there's no more issues of, oh, it works on my machine, why is it failing in Jenkins, spending ages debugging, as I'm sure lots of you are familiar with that pain. And also the other key Docker development, not just the containerizing your services that you need, is the tooling to spin them all up and connect them together. All the networking has been made a hell of a lot easier with Docker Compose. Just in one YAML file, you can spin up all the dependencies your apps needs to run and run its test or just deploy it. And this is the thing we're leveraging most to make our CI pipeline and all our testing strategy a bit easier. We've got things I've liked to call helper images. We've got two key ones that we've been working on, and I'll explain what these are. So what exactly is a helper image? This is kind of a term that I haven't really seen. I might have made it up. But they're just a Docker image that has some very specific functionality that's normally been replicated multiple times. As you saw earlier, we've got lots of different microservices with their own test framework. That will have to have all their own dependencies installed each time. Whereas if it's all baked into one image, the time-consuming work of doing your parallelization, reporting, etc., doesn't need to be replicated across every repo. As a result, your actual app repos are a lot cleaner. You don't have to worry about what's actually happening under the hood with all the complexity. There's no issues with your node version being different to what it's expecting. And there's two core ones that we use to sort of make our tests a lot better. The first one being the test runner, the aptly named. It was just does what it says on the tin. It just happened to be that Blade Runner was coming out, so the styling stuck. There's no pun with flaky tests being replicants or anything, but maybe we could put that in. So this is where we keep all our tooling for WebDriver IO. It lives in its own monorepo, and we push to our own internal Docker registry. So when any consumer or app needs to use it, they just pull it down. And this handles all the relevant things you need, like the running your tests locally in Source Labs, just flip an environment variable. It's got all our shared config that we use across all front-end teams. So things like the browsers we use, the presets, there's our sort of top 10 browsers baked into it. And if you want to run a smaller one, there's a mobile preset, so you can just toggle that, and you don't have to worry about writing your own desired capabilities configs in each of your apps. It also handles the reporting for you, and a big one is the parallelization of tests. Obviously, that's what everyone's keen to do. It makes it a lot faster. You get your feedback cycle a lot quicker, and also it fights flakiness with some features we've baked into it. So I'll just give a little shout out to The Magellan testing framework, the test runner is based on a heavily modified version of this when a load of plugins. Learn a lot from reading their code, so I thought I'd just mention. But yeah, so how do people actually use it? So they pull this image in their, either locally or in Jenkins in their build pipeline. Like I said, it's got the presets and whatever they need baked in. So all they have to do is mount their test files that live in the application repo. You saw that functional tests live directly in the repo. They're not in a separate place that gets run in a separate job. It all gets run in one synchronous pipeline in Jenkins. Yeah, it handles the opening and closing of the Source Labs tunnel, and Docker and Docker Compose are handling some very complex networking under the hood to allow you to talk Source Labs through the tunnel to talk to your various microservices or dependencies that you're running. And also it does the reporting to Source Labs, where it will tag your build name and the application name, and all the tests get labeled neatly in the grouped by build in the viewer, which is great. So parallelization is pretty key. Everyone wants it to be a lot faster. How do we actually do this? Because lots of frameworks do this out of the box. So it's not just per file, which we found that lots of frameworks do. You can have one file with 100 test cases in it in a describe blocks, but the actual test framework normally would only do per one. We've written some custom tooling that will do it on a per describe case, but you can also toggle that so that if you're running it locally, you don't accidentally spin up 30 instances of Chrome and then lock your computer, as I've done whilst developing it. This obviously has a lot of benefits being parallelized. Namely, the most obvious one is it's a lot faster. Like, it's completely linear. If you've got more tests and more VMs, your tests go quicker. Also, if your test sessions, your browser sessions are smaller, it's a lot easier to debug the point at which it went wrong in, say, the Source Labs viewer if you're not running lots of tests in the same session. And they all get tagged in the Source Labs UI like this. You can see here, this is an example of a small feature branch that has a few new tests in it. It's running on Jenkins. You can see it's tagged by our Bitbucket domain as GP. Blue Lobster is the code name for one of our new applications. Obviously, software all needs code names. And then you can see it's tagged with the Jira ticket and then build number in the end. This is all just handled automatically by any consumer using the runner. It's all baked into our sort of tooling. And this leads us on to flakiness, because although you can get lovely reporting, some tests will still get marked as failed. And there's a few things you can do to fight it, but they're time-consuming to set up. So yeah, if you feel like most of your day is like Homer Simpson here, then these are some of the tips we've implemented. So lots of our new apps are all single-page apps. Obviously, that has a few different challenges for sort of testing in using Selenium. You don't have the page load complete happening on page transitions. So we have a few helper functions that will wait for the data to change because the client side is fetching new data rather than a whole new HTML payload being sent from your server. But that's just a sort of a minor thing. That's a new issue. The main issues we have with flakiness are either data, the timeouts waiting for sort of VMs to come up. Sort of, I'm looking at you, iOS emulator. But yeah, and then sometimes you just get errors that you can't predict. Like, you'll just look and you'll see, why did this fail? And there's just some random Selenium stack trace that you couldn't possibly have avoided. So yeah, what we do to avoid this, we have intelligent waiting. So we'll wait, the test timeout won't start until you actually get a VM, which a lot of frameworks, especially in the JavaScript functional testing world, didn't seem to offer. And the other key one is just retrying it. If you can't avoid those random errors, you want to just be able to rerun it and make that not fail the whole build because of one tiny test failing. And the other thing is consistent data. I mean, there's lots of ways around this. So if you're sort of developing against a dev environment API, or sorry, testing against a dev API, you can write some helpers in your test to query the data and then make sure your assertions are on dynamic data. But it would be a lot easier if you just had consistent data and your tests worked every time. So this leads us on to our second helper image, known as the API snapshot, the test API caching proxy service. great naming. So what does this do? This is another Docker image. It sits as a proxy between your app and your real API, so that any request that would go to your API comes back and then gets written to your file system. So any subsequent requests just get returned directly from your file system instead of going back from your API. Obviously, we have some sort of edge cases that we want, like a product that has loads of color variants, sizes, etc. That may not exist because it goes out of stock and we don't want all our tests to fail. So if you can have this response cached and that's used as consistently for every test, that saves a lot of difficulty in keeping your tests from faking out. These responses live alongside the tests in the application repo, so you can, if you want to easily edit it to change it, you can. The kind of like snapshot test, if you're familiar with snapshot test, it's basically like that, but for your API responses. And we have some cool functionality that we've been building in, because in our team, we have the product listing and the product details page app. They're just very sort of like, there's no state involved. Literally everything's just a response and it gets rendered. Whereas services like your wish list or your basket, you can't, if you go get basket, the subsequent call, if you've got a cached mock response, it's going to return nothing. We've done some cool tooling with, if you set a cookie, you can make it so the first call to basket returns 0, but if you add to basket, the second call will return the mocked response with something in the basket, so you can actually do your test like that. And you can also obviously change the response codes, etc., to test that your app functions with errors gracefully. So we've got all this. How does it all actually come together in an easy way to use? So this is actual sort of verbatim copied config from one of our apps that we're developing at the moment, obviously with API keys commented out. You can see here there's 3 services. There's the top left is our affectionately known Blue Lobster, which is our new product listing app. You can see, if you can read the config, it's obviously quite a lot to take in, but it's basically setting the client URL to localhost and then pointing directly to the API snapshot as a server URL, which, like it would be in production, sort of a peered connection in AWS. And then in here, you can see on the API snapshot level, on the bottom, the functional test cache responses are mounted into that container. And then likewise on the functional test runner, which is the one on the right, the actual tests get mounted into that container. So you can see all the various environment variables that get toggled. So if you want to run it locally, you can just turn the source labs to false, and that'll go away. If you want to just not use a preset, you can uncomment out one of those lines, like the iPhone browser. And yeah, if you want to run it locally, you can choose your browsers there with source labs false, and it will run locally to your Selenium host running on the usual Selenium ports. So it sounds like a lot of config, but actually this is the only one file you need really for doing all your functional tests in Jenkins or even locally. So you can run it with all of this gets spun up with just these 2 lines at the bottom. You have the top one just fetches the latest version of the API snapshot and the test runner itself. And then the second one spins up all the services, links them all together, and then the functional test runner will open all the connection to source labs, and all the tests get run against both the app and the API snapshot service. And then if the tests fail from the exit code in the runner itself, that returns out, spins down all the microservices, and then your test or your build will fail in Jenkins. So this is what it actually looks like in Jenkins. You can see here, you've got Jenkins, the red bit, Docker Compose is the blue bit. So in Jenkins, you have your latest bit like commit. It will pull the file system with your Compose YML file, the API responses, and the actual tests. All these containers get spun up, and your API responses and tests get mounted within them. And then the next thing happens, the test runner will start. It will have read how many tests you've got in there, how many browsers you wanted to do it. If you had 20 tests and 8 browsers, it will request 160 sessions. So it opens the tunnel to Jenkins, and this allows Source Labs to connect to all the various containers with the networking mode host that the test runner runs in. And then you can see it does your usual stuff with sending all the Selenium commands to Source Labs. And then the server-side HTML ones go directly to the web application, but because we're testing single-page apps now, lots of the data just comes from the browser requesting it. So that goes, as you can see, directly to the API snapshot service. So hopefully everyone can take that in. Obviously, I'm familiar with that, but it's probably new to quite a few people. So after we've done all that, what actually did we get from it? So the main things, I kind of said this before, it's a lot less config in the app repos. You get a lot of benefits without having to write lots of tooling that had been duplicated previously a lot. The tests end up going a lot faster. You get the reliability with some of the anti-flakiness features. An exact consistent running environment in your Jenkins and locally. You run the exact same command that was listed a couple slides ago. If you run that on your machine, you'll get exactly as it runs in Jenkins. And because they're all, the actual helper images live in their own repos and the tooling all lives in there, if you wanted to update the browser matrix and push a change to that, all consumers of the runner, next time they run their test, will get their test in the latest browsers. So it's pretty cool to just be able to ship things like that. Open sourcing it all. This was something I was really looking forward to getting to with a one more thing style end slide. Unfortunately, as you probably all know, software development doesn't always go on time, especially when it's not your main business function. And so it will be coming quite soon, hopefully, in the next sort of few weeks / month. But I'm working on it. And that's it. Thank you very much for listening. Does anyone have?
You want to take a couple of questions? We have time for a handful of questions.
Okay, I think
Yeah,
we've
it says
got
two
2
minutes.
minutes left.
Okay, 2 minutes.
One.
Hi, yes. I'm not sure if you mentioned this, but in your tooling in the Docker images that you have, I'm assuming reporting in there as well, just having some type of tooling for reporting. And then the follow-up question that's going to be there is, have you thought about like treating that as its own Docker image so that since you have the API one and then you have the other runner, those both can talk to a centralized reporting, so the two Docker images would talk to each other, be able to kind of have a consolidated type of reporting, something like that?
Yeah, so the API snapshot doesn't actually do any reporting of itself. It's purely just a caching service. But the reporting, the actual runner you can obviously config what it will do in the central repo. It gets rebuilt on every commit you push to the actual runner's code. But the reporting it does is obviously Source Labs, and we do have a sort of working prototype where you can make it write JUnit reports back to Jenkins just as you would with a normal test framework, and we sort of handle lots of the Docker user ID issues with that. But yeah, if you wanted it to report in other places, like if you had your own dashboard, if you added that functionality to the code, then everyone else could use that. So that's something we're sort of looking forward to being able to do in the future, and if it becomes open source, allow it to be extended by people who want to add that functionality.
One more?
Got 50 seconds.
Simple question. Showed gates. What type of threshold promote going from one stage to the next? You had green. What's your green? What does green mean? 100% pass of all the tests, or is it something different?
Do you mean the Source Labs, the automated build in Source Labs?
And the promotion. When you were showing the gated approach of promoting from one stage to the next.
I think at some point we had 98%, but that was just for unit tests. For functional, it has to be, you have to have 100%, otherwise the build would fail. We've reinforced that just because we wanted everyone to be aware that if you're writing tests, they have to pass in order to follow to the next step.
Well, thank you very much.
We've got 2 seconds left.
Yeah, I got a couple of quick announcements for everybody. Lunch is from 1 to 2 in the Embarcadero room, 3rd floor downstairs, and dessert is in the exhibit hall out here. And special thanks to Dynatrace, our sponsor, for lunch. Thanks. Thank you very much.